Next up, moving on to statistics, we have measure of center. Now this is going to include stuff like mean, mode, median, range, and all that type of stuff. So let's get started. First up, we have mean. And mean just means the exact same thing as average. So to find the mean or the average of something, you just take the sum of all numbers and then you divide it by the number of numbers. So for example, I have this list right here of 1, 2, 3, 4, and 5. The sum of all the numbers would just be 1 plus 2 plus 3 plus 4 plus 5. And then the number of numbers would be, well, there's 5 numbers. There's 1, 2, 3, 4, and 5. So it will be divided by 5. 1 plus 2 plus 3 plus 4 plus 5 is just 15. And then 15 divided by 5 is 3. So the mean of this data set would be 3. Now if you don't want to do all that math, of course you can always use desmos. So here I am on desmos, and the first thing you're going to do is put in that list. So to make a list, you're going to choose any capital letter. You could choose A, B, C. Wait, that was even C. Anyways, it doesn't matter. You just have to make sure it's a capital letter. So I'm going to choose L for list. And then you're going to put the equal sign. And then you're going to put this bracket. And you can see here, it says list. And now you can just start typing in your numbers. So I'm going to do 1, comma, 2, comma, 3, comma, 4, comma, 5. And then I'm going to close it. And then now to find the mean, all you have to do is type in mean, parentheses, and then you can put in whatever letter you put here. So I'm going to put L. And then right here, it'll give you that the mean is 3. Now this is especially useful when you have like a super long list. So let's say I just started putting random numbers in here. And there's just a whole bunch of numbers now. And of course, it doesn't matter. It'll still give you the mean. Moving on, we have the median. Now the median is going to be the middle number of an ordered list. Now, if you're trying to find the median by hand, it's going to be super important that it has to be an ordered list. So here's an example. We have the exact same list of 1, 2, 3, 4, 5. And then all you have to do is find the middle number. And you can do this by just crossing out the first and the last numbers. So you can cross out the 1 and the 5. And then the 2 and the 4. And you get that the median is just 3. Now, let's say we had this bigger list where we have a list of the average grades of 25 students. So we have 25 elements in this list. Of course, you could go crossing it out. You could do 72, 93, 75, 92, but that would just take a whole bunch of time. Instead, there is like a little trick that you can use. And if you have a list with an odd number of elements, the position of the median is going to be the number of elements divided by 2, rounded up. So basically, we have a list of 25 students, right? So we're going to do 25 divided by 2, which is going to be 12.5. And you always want to round up if it's going to be an odd number. So 12.5 rounded up is 13. And now all we have to do is count to the 13th spot in this list, and that's what our median is going to be. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, our median is going to be 84. Now let's say we were trying to find a median of an even number of elements. So here in this list, we have 1, 2, 3, and 4. And if we tried crossing off the beginning and the end, we'd cross off 1 and 4. And then 2 and 3, we would see that there's nothing left in the middle. So what we're going to do instead is we're going to take the 2 middle numbers instead of just the 1 middle number. We're going to take the 2 middle numbers, we're going to add them up, and then we're going to divide it by 2. So here in this list, our 2 middle numbers would be 2 and 3. So we're going to do 2 plus 3 and divide that by 2. 2 plus 3 is just 5, and then 5 divided by 2 is 2.5. So our median in this list would be 2.5. Once again, here's a larger list, and it's going to be a list of the average grades of 24 students. So this time, we're going to have an even number of elements, because there's 24 students. Now you could go crossing off the beginning and the end, so 72 and 92, 75 and 91, so on and so forth until you reach the middle. But just like with the odd number of elements or the odd number of students, there is a little trick that you can use. Now, when you have a list with an even number of elements, your median is going to be the average of the 2 middle numbers. To find your first middle number, all you're going to have to do is do the exact same thing you did when you have an odd number of elements. So that's just the number of elements, which is 24 here, divided by 2. So 24 divided by 2. And that's going to be 12. Now to find your second middle number, all you have to do is take this number that you just got and add 1 to it. So 12 plus 1 is 13. Now, this means that your median is going to be the average of your 12th value and your 13th value. So let's go ahead and find those two values. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So it's going to be the average of 84 and 84. And of course, the average of those two numbers is just 84. So our median would be 84. Now, just like mean, you can also find the median in desmos. And it doesn't matter how many elements you have. You can have an even number, you can have an odd number, you can have 100, alright? It doesn't matter. You can just put in desmos. Here I am on desmos, and just like with the mean, first thing we're gonna have to do is put in our list. So, any capital letter, I'm gonna just choose L again, equal to, and then the bracket, and now I'm gonna start typing in my list. So 72, 5, 6, 7, 8, 9, 8, 1, 8, 2, 8, 3, 4, 5, 6, 91, and 92. And of course, you always want to make sure at the end that your elements matched up. So I did copy the list from the average grades of 24 students, and it does have 24 elements, so it does match up. Then you're gonna type in median like that, and then parentheses and the letter you chose here, so L, and you get then the median is 84. Now if I went ahead and typed in the number or the last number to get 25 elements, just like our first example, we will get that the median is also 84. So there you go. Alright, I just realized that was kind of a bad example because they had the same median. So let me try adding like a whole bunch of random numbers. So 24, alright, I'm just typing random numbers. And you can see that it still gives you the median. Moving on from that, next up we have mode. And your mode is just gonna be your most frequent number. So here in this list, we have 5 1s, 4 2s, 3 3s, 2 4s, and 1 5. So our most frequent number is 1, which means our mode is 1. Unfortunately, you can't find the mode on desmos. Oh no, my glorious desmos. But to be honest, who would need desmos? I mean, just look at it and which one pops up the most, alright? And if they give you a table, it literally gives you the number of how many times they show up. So just look for the biggest number, and that's your mode. Then we have range, and your range is just going to be your maximum number minus your minimum number. So here in this list of 1, 2, 3, 4, and 5, our maximum number is going to be 5, and our minimum number is going to be 1. So our range is 5 minus 1, which is just 4. Now let's say we have this list right here, which it's definitely a lot more chaotic. First things first, it's not ordered, alright? It's not from least to greatest. And then it's just a whole bunch of big numbers, and it might be a little hard to find out what the maximum and the minimum number is. But of course, don't worry because Desmos always got your back, alright? I love Desmos. Desmos is always... Alright, so here I am on Desmos, and just like we did for the mean and the median, first things first, we're gonna have to put in our list. So choose any capital letter, and then you're gonna put in our list, and you know, I learned my mistake from last time. I'm gonna just copy and paste it in, alright? So here's our list, and then you can't actually type in range of L like this. That doesn't work. However, you can find the max and the min, and to do that, all you have to do is type in max, and then whatever letter you chose to name your list, oops, and then it gets you the max, and you can also do the min. And now you can find your range by just subtracting these two. And you get that your range is 457. So once again, you can't type in a range directly, but you can find the maximum value and the minimum value. Moving on, we have box plots, and you do need to know how to read these, but it's honestly not that much. The first thing is that this very leftmost line is going to be your minimum value. Then this middle line, that's going to be your median. And this right line, or your rightmost line, is going to be your maximum. And honestly, that's it. Like, there might be stuff like first quartile or something like that, I forgot what it was. But you don't need to know that for the sake of the SAT. They might try to trick you though, and give you a box plot that looks like this. So of course you still know that this left line right here, that's going to be your minimum, and then this right line, that's your maximum. But you might be doubting now, because this middle line, which would normally be your median, is not in the middle anymore. Like, it's really far to the right. But it does not matter, alright? That middle line is still going to be your median. And I also really quickly wanted to show you that you can also draw box plots in Desmos. So first thing, as always, put in our list. So any capital letter is equal to, and now I'm just do 1, 2, 3, 4, and 5. Super basic. And then you can type in boxplot and L. And there you go, it gives you the box plot. So here, 1 is our minimum, 5 is our maximum, and 3 is our median. Now, I'm not gonna lie, I don't know when this would ever be useful to you, but I just thought it was a cool thing to know, alright? And if you want to know more stuff, you can click the keyboard here, and then functions. And if you scroll to statistics, there's all this other stuff. So of course we have mean, median, min, and max. And they have like quartile and quantile, whatever that means, and whatever all these other thingies are. But I just wanted to quickly show you because I thought it was cool. Moving on, we have standard deviation, and all this means is how spread out the data is. So here I have two lists of SAT scores, and for class A, it ranges from 950 to 1020. So as you can see, the gap is not really that big. Whereas in class B, it ranges from 800 to 1600. So now there's a super big gap. It goes from literally 3 digits to 4 digits. Well, you know what I'm saying, right? There's like an 800 point difference. So this would mean that class B has a greater standard deviation than class A. But in some cases where it's not as obvious, you can always put in desmos. Here I am on desmos, and just like we've been doing, let's put in our list first. So any capital letter equals to, and the bracket, and let me type these numbers in. 960, 960, 980, 1000, 1000, and 1020. And then for our second list, I'll have to choose another letter. I'll just do a 800, 1000, 1250, 1200, 1200, 1250, 1600. Alright, so now we have our two lists. And now all you have to do is type in STDEV, which stands for standard deviation. And then our parentheses, and let's do for our list L. And we get that this is the standard deviation. And then let's do it for list A. Oops. And we get that this is our standard deviation. And as you can see, the second list is way bigger. Wait, I literally called it class A and class B. Why did I not just do A and B? Well, anyways, this is all you're gonna have to do. Just compare their standard deviations. You don't need to actually like understand it or use it or anything like that. All you need to know is one has it bigger than the other. Moving on, we have dot plots, and the only thing that you really need to know for dot plots is that the more clustered the dots are, so the closer they are together, the smaller their standard deviation will be. And the less clustered the dots are, or the more spread apart they are, the greater their standard deviation will be. You can also plot these on Desmos, so let me show you what that looks like. Here I am on Desmos, and just like with everything we've been doing, the first thing you need to do is make your list. So choose any letter equals to, bracket, and then I do have this set of points, so I'm gonna copy and paste that real quick. There we go. And now you're gonna type out dot plot, parentheses, and whatever letter you chose to name your list. And here is your dot plot. Now, you can see that it's more clustered, and this will mean that it's gonna have a smaller standard deviation. I also have the second set of points, or list or whatever. There we go. And then dot plot. And as you can see, this one is more spread apart, or it's less clustered, and this means it'll have a greater standard deviation. So just by looking at it, you can tell that this one will have a greater standard deviation compared to this one. Now, you could always just use the standard deviation function to find it out. So let's do that. Standard deviation L is that, and the standard deviation A is that. So the more spread out one has a bigger standard deviation, and the more clustered one has a smaller standard deviation. Lastly, we have symmetric distribution. Now, all this means is that the data is evenly spread around a central value, or that it's mirrored. Now, I know that the definition doesn't make a lot of sense, so I do have a few examples. The first one is this dot plot. Now, as you can see, 2, 2, 3, 3, 2, 2, 1, 1, and then you have the middle. So it looks the same on both sides. Now, I also have another dot plot where it's this pyramid. So you have 1, 1, 2, 2, 3, 3, and then your middle. Now that's what a dot plot would look like, but if you just had a list, then it would look like this, where you have 2, 2, 4, and 4, and then your middle. And whenever you see these patterns, you can instantly know that the mean is equal to the median. Alright guys, that's all there's gonna be for the measure of center. Now, I know that was a lot. Mean, median, mode, range, box plots. I'm not glad I already forgot the rest. But most of it is super easy, and really half of it you can already put into Desmos and it'll do it for you. So, hopefully it wasn't too bad, and I'll see ya.